Hi, Med Geniuses. Welcome to another biochemical series. It is your great science teacher Lorenzo, and today we'll be dissecting what fructose metabolism. If you are new to my channel, make sure to subscribe and turn on your post notification button so that anytime I drop any video, you'll be sure to be notified. And if you are studying anything and you have issues with your study, or you want me to teach any topic that you need, please just write it down in the comment section. When I go to it, I'll make the video for you. So let us jump right into the video. So in fructose metabolism, just like we did in glucose metabolism, which is what glycolysis. So how is fructose broken down? Fructose is very important because fructose is gotten from sucrose. So sucrose uses sucrose and break it down to what glucose and what fructose. So in the small intestine, fructose is what absorbed the same way glucose is absorbed, and they are transported what using what we call GLUT5. So GLUT5 transport what fructose to the tissues, and when GLUT5 transport tissues, so we are talking about fructose in the liver. So fructose can be metabolized in the liver, in the kidney, in the muscle. So when fructose is metabolized in the liver, it's different from when fructose is metabolized in the muscle. So in the muscle, fructose can be converted to what fructose phosphate, which will be also be a substrate for what glycolysis. But in the liver, fructose is metabolized to form a different thing, which we'll be discussing. So fructose is a sweet sugar, so it is gotten from the isomerism of what glucose. So when it is an isomer of glucose, because when you isomerize glucose, you get what fructose. So the difference between glucose and fructose is glucose is an aldose sugar, while fructose is a ketose sugar. So the ring two are different. Glucose is a pyranose, has a pyranose backbone, while fructose has a furanose backbone. But both of them are different, and fructose is more sweeter than glucose. Don't forget. So in fructose now, in the metabolism of fructose in the liver, what happens? Fructose first of all is phosphorylated at carbon 1 using fructokinase. So fructokinase phosphorylate fructose at carbon 1 to form fructose 1 phosphate. Again, fructokinase phosphorylate fructose at carbon 1 to form fructose 1 phosphate. Fructose 1 phosphate. So if fructose in the liver is converted to fructose 1 phosphate by fructokinase, but in the muscle and the kidney, fructose is converted to fructose phosphate by hexokinase, which will form a substrate of glycolysis. Don't forget. When you cleave fructose 1 phosphate with Aldolase B, when you cleave it with Aldolase B, what will you get? You will get DHAP, which is dihydrogen artisanal phosphate, and glyceraldehyde. So remember, in glycolysis we say that dihydrogen artisanal phosphate can be shunted for lipogenesis formation, but here we don't want lipogenesis. We want to continue the process of fructose metabolism. So we'll convert dihydrogen acetone phosphate to GA3P, which is glyceraldehyde 3 phosphate. Don't forget. So just like in glycolysis, DHAP is converted to GA3P, which is glyceraldehyde 3 phosphate by phosphotrioisomerase. So now we have glyceraldehyde and glyceraldehyde 3 phosphate. Glyceraldehyde 3 phosphate is a substrate of glycolysis, while glyceraldehyde is not a substrate, so it's converted to glyceraldehyde 3 phosphate by glyceraldehyde kinase. So glyceraldehyde kinase converts glyceraldehyde to glyceraldehyde 3 phosphate. So we now have two glyceraldehyde 3 phosphates. So don't forget, the first glyceraldehyde 3 phosphate is gotten from DHAP, which is dihydrogen acetone phosphate, by phosphotrioisomerase. So phosphotrioisomerase convert DHAP to GA3P, while glyceraldehyde kinase convert glyceraldehyde to glyceraldehyde 3 phosphate at carbon 3. Don't forget it. If you are staying with us throughout this video, hope it all made sense and you understand the metabolism of fructose with all the outlines I gave, and I taught you how fructose is absorbed using GLUT5 and it transported to the muscle. In the muscle, it's converted to fructose phosphate, which continues with pyruvate formation, and in the liver it is metabolized to form intermediate of glycolysis. So I hope you understood all this stuff. If you are new to my channel, make sure to subscribe and turn on your post notification button so that anytime I drop any video, be sure to be notified. And you have any question or you want any video to be made for you based on any topic, maybe put it down in the comment section. When I go to it, I'll make the video for you. See you in the next class. Thank you. Goodbye.